So now we will solve some of the objective type questions which are very useful for get point of view. So first I am writing the problems here. Just taking the problem. First I will write the problem here. So problem is the state of pure substance. Suppose this is problem number 1. State of pure substance can be fixed by specifying a one property b two properties c three properties and four none of these none of this. So now let's solve this problem. So now we are having the Gibbs phase rule. According to Gibbs phase rule, we are having F equals to C minus P plus 2. Suppose in a pure substance can exist in one phase, can exist in two phase, can exist in three phase. Suppose we are talking about pure substance with one phase. So I am talking about pure substance with one phase. So we are having C equals to 1, P equals to 1, and if we plug in that formula, we will get F equals to 2. So two properties is required. Similarly, pure substance can exist with two phases. So second case I am considering pure substance with two phase. So here C equals to 1, P equals to 2, and if we plug this thing in that formula here, P is 2, so minus 2 plus 2, so F I will get 1. Similarly, pure substance can exist with three phase. So pure substance with three phase. So C equals to 1, P equals to 3, so F will be 0. So now these are all the possible cases with pure substance. We required 0 properties, we required 1, so we required 2. So maximum we require 2 properties. So the state of pure substance can be fixed by specifying 2 properties. So I am mentioning 2 properties here. So the correct answer is B, 2 properties. Now I am taking the problem 2. I am just writing the problem. A pure substance is a two component system existing in one phase, one or more phase. B, one component system existing in one phase. C, two component system existing in one phase. D, one component system existing in one or more phases. So, according to the definition of pure substance is a substance of constant chemical composition throughout its mass. It's a one component substance, but it may exist in one or more phases. So, according to that, D will be the correct answer. So, correct answer is D, one component system existing in one or more phases. Now I am taking the one more interesting problem, problem number 3. I am just writing the problem here first. The slope of the isobar in a Mollier chart or Mollier diagram is equal to A, enthalpy, B, dryness fraction, C, temperature, or D, pressure. So now let's solve this problem. Here we are interested in slope of the isobar in a Mollier diagram. So Mollier diagram is nothing but enthalpy entropy diagram. So I am writing here Mollier diagram is nothing but enthalpy entropy diagram. Entropy diagram. So now with the help of first law of thermodynamics, we can write this thing, that is del Q equals to dH minus Vd. We can write with the help of first law of thermodynamics, that is first law of thermodynamics for flow process. And now we know del Q equals to TdS for reversible process. So if I put del Q equal to TdS in this equation, I will get TdS equals to LH minus Vg. Now we are talking about slope of the isobar. Isobar is nothing but constant pressure process. So in constant pressure process, P equals to C, so del P will be 0. And if I put del P equals to 0 here, I will get T ds equals to LH. And slope of the isobar in a Mollier diagram, slope will be dH by d. The slope will be dH by ds, so it will be equals to T, temperature. So the slope of isobar in Mollier diagram will be equals to temperature. So correct answer is C, that is temperature. Temperature will be the correct answer. So now let's take an problem number 4. I'm just writing the problem. A saturation state has how many degree of freedom? Degree of freedom means how many independent properties are required to define the system. A, maybe 2, B, 1, C, 0, D. So now again apply the Gibbs phase rule. I am applying the Gibbs phase rule. According to Gibbs space rule, degree of freedom equals to C minus P plus 2. At saturated state, we are having two phases. So P will be 2, P will be 1, and if we plug here, then F equals to 1 minus 2 plus 2. So F equals to 1. So the degree of freedom required for the saturation state will be 1. So correct answer will be that is 1. Now let's take problem number 5. I am just writing the problem 5 here. Water is contained in a rigid vessel contained in a rigid vessel of 5 meter cube at a quality of point 0.8 and a pressure of 2 megapascal. If the pressure is reduced to 400 kilopascal by cooling the vessel, find find the final find the final mass of vapor, that is finished. So now we have to find out the final mass of the vapor. In this problem, water is contained in a rigid vessel of 5 meter cube volume with a quality means dryness fraction of 0.8 and the pressure is 2 megapascal. If the pressure is reduced to 400 kilopascal by cooling the vessel, then we have to find out mass of the vapor. So now let's solve this problem. So I'm just solving this problem. So I am using the steam table. So from steam table, and generally in GET problem, as I already mentioned in previous question, they will give a small table or they will provide the data. So on steam table, we can find out the specific volume of the mixture. This is our formula Vf plus X Vg minus Vf, and now we can plug the value of Vf, Vf and X. Vf, Vg we can get from the steam table. So now from the steam table, Vf is 0.00118 plus X, we know that is quality 0.8 is given in the problem. Vg is 0.09963 minus 0.00118. So these are the properties at 2 megapascal. So now if we solve it, we will get the specific volume of mixture. It is 0.7994 meter cube per kg. So now here whatever value I am taking from the steam table. So I am getting the specific volume of the mixture. Now here it is mentioned in the problem it is a rigid vessel, so the volume will remain constant. So I can write vessel is rigid, so volume will be constant. Means if we are getting volume at 2 megapascal, suppose specific volume I am getting 0.07994. So same specific volume I will get for 400 kilopascal also. So I can write at 400 kilopascal specific volume will be 0.7994 meter cube kg. So now I can again write the specific volume of mixture is Vf plus X Vg minus Vf. Here we don't know the quality of steam or dryness fraction. So here we will find the dryness fraction when the substance is at 400 kilopascal. So we already calculated point 0.7, it is point 0, sorry, that is point 0.7992. I'm again writing here that is point 0, there it is point 0. Okay, so that is 0.07994 plus to Vf at 400 kilopascal, 0.0011 plus X we have to find out Pg at 400 kilopascal, 0.4625 minus 0.0011. If we calculate this thing, we will get 0.1709. So the quality of substance at 400 kilopascal is 0.1709. Now we have to find out the total mass of the water. We can easily find out total mass of water, that is M. We can find out this total volume or specific volume. Total volume we are having 5 meter cube and specific volume we are having 0.07994. So we are having M equals to 62.55 kg. Now we are interested in mass of the vapor. So mass of vapor we can easily find out equals to X into M by dryness fraction formula. X we calculated 0.1709 and M it is mass of the water, total mass 62.55. So the mass of the vapor will be 10.69 kg. By this way we can find out the mass of the vapor, that is 10.69 kg. Let's take in problem number 6. I'm just writing the problem number 6. The slopes of sublimation, vaporization, and and fusion for most of the substances are positive. Name one material whose fusion curve is negative. So our options are A. Argon, B. Dry ice, C. Liquid nitrogen, and D. Water. So now, if we will see the property of water, by this way we can understand um, the slope of the sublimation, vaporization, and fusion for water will be negative. So because I am writing one thing here for this solution, for most of the material, for most of the substance contracts during freezing, but water will expand during freezing. It means during freezing the volume of the water will increase. So for this problem we can see that when most of the substance contracts during freezing, at the same time water will expand during freezing. Means it's showing the behavior opposite to the other substance. So the correct answer for this problem will be D, that is water. So water will be the